Hello everybody, welcome to another live stream on Nerdcraft. I don't think I've ever introduced myself in one of my videos before, so my name is Drew, by the way. So today I thought that I would show some of the techniques that I have learned for creating a black hole in Blender. And in future live streams, I would also like to show other techniques that I have developed and am still perfecting for other types of space art. Galaxies, planets, and so forth. But this week I did not have time to prepare all of that, and fortunately I have found that making a black hole is pretty easy in Blender. So what I've done so far is I've just set up a scene, which is not super fancy, but later on we can add to this a little bit more, but just so that we can get to the main topic of creating our black hole. So all I have done is created an accretion disk, which is basically like, you can think of it as sort of a Saturn's ring that is probably often found around black holes in real life. And of course, we've seen that in some of the images that we have seen in telescopes recently. And I decided to make the scene a little bit more fun than just a black hole. I've actually put a nebula around this so that we see some clouds of gas and such swirling around, and which might also make seeing the effect that the black hole has of bending the light a little bit more fun to look at. So let's go ahead and get started. So first off, I'm going to show how to create the black hole itself. So let me go into solid view here, Shift-Alt-Z, and let me turn on my screencast keys, just in case anyone finds that useful. So what we are going to start with is we are going to add a sphere. Now I like to add an icosphere here, just because a UV sphere, I don't know, I don't see any need for all of the triangles and stuff. But an icosphere has very even topology, or anyway, it's made up of triangles. And so we're going to turn the subdivisions up to probably 6, just so that this is smooth enough. We want this object to be smooth, so that high poly enough to be smooth, so that the shading effects that we're going to add in a bit with the bending of light, so that that is consistent and doesn't have any little glitches with seeing the vertices and the faces and such. So that's all we need there. Now let me kind of describe what we're going to be doing. So with a black hole, the way it works is you have the black hole itself and what we'll call the event horizon. But there is a region around that event horizon, around that black hole, where light starts to bend, such that if you're looking at a spot close to the edge of that black hole, the closer you are to it, you're actually seeing part of the universe from over here. The closer you get, the closer you look from this direction. So we're going to, what this sphere that we see here, what it represents is, it represents not the black hole itself, or at least not the event horizon itself, but it represents the space around the black hole, where we want it to appear that space is starting to bend around it, and light likewise is starting to bend. So the material is pretty easy. I'm just going to call this material black hole, if I can. So what we need is a material that will bend light. So we are going to add a refraction BSDF shader, and we're going to plug this into the surface. Now what we're going to be doing in this video is technically kind of cheating, because again, a black hole affects the space around it. Whereas what this refraction shader that we're adding, this just adds material to the surface. However, I found that if we utilize this the correct way, we can actually get what visually is the same result and should be accurate to what a real black hole would look like, which we will see a bit later. So let's see what this looks like in rendered view. And quickly, I am going to turn off with my own custom keyboard shortcut, which I guess isn't working right now. I'm going to turn off my compositing stuff, just so it's a little bit faster. So right now, this whole object is bending light rather like a magnifying glass. So But you notice if we play around with our IOR, our index of refraction, this affects, of course, how much light bends. But the closer we get to 1, we notice if we have our index of refraction set to 1, then light goes straight through. What we want is we want the very edges represented by this orange line that we see. We want areas close to that to have an index of refraction of 1 so that light would just go straight through. But the closer we get to the part of that sphere facing the camera, it will bend light more. So that appears that the black hole is bending light a lot close to it, but the closer it gets to the edge, it fades off into space, into not bending light anymore, or not bending space. Unfortunately, there is an easy way to do that. We are going to add a layer weight node. Now, if we visualize what this is doing, and by the way, I seem to have an artifact here. You notice that part of, let's see, oops, if I hit the correct button here, you'll notice that part of our accretion disk is like a little bit darker because it's inside, it's on the other side of our sphere that we created. And I finally figured out that the way to fix that, which I think the settings are this way by default. Let me find the settings again. If I go to light paths, yes, it's in light paths. So if you're having this problem in any kind of project where things inside of a glass material or something aren't bright enough from behind, you have to go to light paths and go to clamping here and take this indirect light, which I think I have this set at default, so yours might be set to 10 by default as well. I don't remember if this is my own setting or Blender's default, but just turn that indirect light clamping to 0, which will actually mean that it won't clamp it anymore. And that fixes that problem. So let's visualize what this layer weight that I told you to add does. If we shift control click with the Node Wrangler add-on, we see if we just look at our sphere, this gives us a value of 0 or black on the parts of the mesh that are facing the camera. But the parts that where the normals are not facing the camera, they're kind of at a 90-degree angle, it gives us a value of 1 or white. What would be visualized as white here. And that's what we want. So that's the start. But what we want in this case is we want this to go from a value of 1 on the edges, because again, we want our IOR to be 1, which it already is that, but instead we want the IOR to go up, to go greater than 1 toward the middle, not black. That is what we want in this case. So I found a good way to do this is to, let me look at my references again, is to add a map range node. Basically, we're going to invert this a couple of times. And I'm going to place this here. And now we see it goes from black to white in the middle, but we want it to go from white to greater than white. We'll get it there in just a bit. Is it okay if clamping is on? I think this time it's okay, but we're going to reverse it over here. Now, the reason we're inverting it twice is because we need something else to happen in between here. We're going to add another math node, and we're going to set it to power. If you've watched my previous videos, then you know that a math node set to power is one of my favorite things. I use it all the time. And we are going to give this an exponent of, what did I set mine to previously? Something like 8. Now what this will do, you'll see how this white area has expanded, and this black area in the middle represents where light will be bent even more. But wherever it's white, which I know it looks gray right here, but that's just because of the exposure of our camera, it'll make it look like light is not being bent very much. That way we'll get a very smooth fall off into the bending of light. And then, looking at my notes, I can't remember exactly why this worked because I've been a bit busy to remember exactly. But in order to get that to go from 1 to greater than 1, rather than 1 to black or 1 to 0, let's add another math node, set it to divide. I remember why this works now. And we'll place this over this, but we want this to be in the second slot. And we want our first value to be a value of 1. So it's 1 divided by this. So here in the middle it gets brighter because 1 divided by lower numbers is a greater number. 1 divided by 0.25 is 4, for example. So that gives us a factor that we want. Now let's use this the way we intended to. So let's visualize our refraction again. And it's an IOR set to 1, which means light will go straight through. But if we plug this in, let's see what happens. And what do you know? We get our first black hole. So this is bending light. We can see that it looks like the part of the accretion disk or the Saturn's ring that is behind the black hole. It almost looks like we can see it around the black hole. What it's doing is, if you look at the spot just above, like if you were to look at this spot just above the black hole here, you're actually getting light that is from behind the black hole. And that's basically the way it would work in real life. And fortunately, we are also able to replicate that in Blender. So now that we have that, I'm going to adjust some things that I have done here just to make it look kind of nice. I'm going to select my accretion disk. And of course, I didn't do this in this video. I set this up beforehand, but I have a few kind of crazy controls where I can control how far the accretion disk, how close it is to that black hole. You'll notice that there's sort of a region on the inside where it is completely black. If I guess I'm still full screen, like this area, you can kind of see the edge here, kind of like that. I want to bring the inner edge of my accretion disk right up next to it, maybe about there. And I'm actually going to make my accretion disk not quite so big, so I'm going to turn this to, say, -1. That's probably going to be too small, maybe about like that. It's kind of a nice looking accretion disk there. But yeah, now we get this neat effect. But now we still have some problems. Like I said, this black area that we have, we are still getting some image coming through. So in order to fix that, and let me just double check and make sure that I have everything the same in my reference file that I have here, and it appears I do. One thing I am going to do really quick is I'm going to make the accretion disk a little bit thinner, because it's very thick right there. Let me remember how I did that. Let me just turn this down to maybe 0.02, maybe 0.01, and then I'm going to make that accretion disk brighter so it still looks cool. And then we shall move on. We turned up to maybe about 1,000. Let's try 5,000, make it really bright. There we go, that's pretty neat. So yeah, let's go ahead and fix that really quick. So I'm going to go back into my black hole, and I'm actually going to introduce another fix that I found. That I'm not the smartest person in the world as far as knowing for sure the mathematics of how exactly black holes and such work, but I believe that the closer you look toward the event horizon of the black hole, everything should be redshifted, which is a technical term that basically means if there was a blue color there, then it would be shifted over to like green and yellow, orange and red, and therefore if anything were green in there, it would be shifted over to yellow and red. And we can't do that precisely the way it would be done scientifically in real life in Blender, because Blender doesn't use wavelength data, but we can approximate it. So what I'm going to do is I'm going to get it to change color, and let me look at my notes really quick, and I am seeing hearts in the chat. Thank you very much for those who are tuning in right now. So let's see, I have a map range, and then I have another map range that inverts it. Okay, so what I'm going to do, by the way, as long as there are people in the chats, or if you are watching this in replay as sort of a tutorial, just on the topic of space, I'm always curious to know what people believe. The universe is such a big place, but of course there's the Fermi paradox, which means that basically we don't have proof that we're actually seeing aliens out there in space. So I'm always curious to know what people believe as far as, do you think that there actually is life out there? Do you think that Earth is the only world with life in the universe? I have my own opinions, but I'd like to hear your guys' opinions. So what we have to do is I'm going to use the same factor that we created. Let's just visualize that again, just to remember what we're doing. And what I'm going to do is I'm going to take this factor that goes from 1 to 0, at least at that point, and have it be the closer it is to black, then the more we tint anything, any image behind that black hole more toward red. And I'm actually going to shift it toward yellow and then red, just so that we see kind of a, not quite a rainbow effect, but at least it might have the illusion of kind of shifting colors. And as it would have it, I've found that we have to, so let's just visualize what we're doing here. I'm going to basically invert it, flip this from 1 and 0 to 0 and 1. But in order for it to be 1, a value of 1 or white at where we see black in this shader, I left a lot of room here because I know I'm going to need it. Right where it turns black there at first, I found, at least in the setup I did before, that our first value has to be set to 1 divided by pi, which you can just type in 1/pi. And yes, and as long as our clamp, if we look closely, we see, let me just visualize this really quick with a greater than set to 1 or 0.999 maybe. So now we see that should be, and maybe it's not, but it should be about the same size as the black of our black hole. It's pretty close, but either way, that's the value that I used before. I'm going to get rid of that greater than thing there. Now I'm going to add another math node. Let's visualize that to see what we're doing, and I'm going to set this to power again. I'm going to plug this here. Now again, wherever it goes from black to white, or grayish, even though it looks that way, that's where it's going to fade to red. So I want that to be very tight around the edge or the event horizon of the black hole. So if I turn this power up, in a previous video I was trying to describe what this power function on math is doing, and I couldn't quite describe it, and then I remembered that there actually is a way to just show what's happening here. If I go to like RGB curves, basically what this power is doing, if it's set to 1, then you just have 0 to 1 straight. But if you turn it up to like say 2, then it's almost like drawing a line from a value of 1 toward halfway, but of course it curves along the way. So it's flat here, and then it goes from here to there. It's very technical, but it's very handy nonetheless. However, whether you know what it does or not, it's very handy to use. So I set my power to 8 in my previous one, so now it'll fade to red just barely around the black hole. And then we're going to use some color mix nodes, and what I would rather do is I would rather have it be a value of black in the middle and white on the outside. So I'm just going to invert that basically again. And now, let me look at my references again. I am going to add 3 different color mix nodes. So I have it in my quick favorites by pressing Q, and I'm going to add a color mix node. And I'm actually going to add 3 of these. One is going to take the image behind and shift it to yellow, and the next one is going to shift it to red, and then the next one is just going to shift it to black when it goes into the black hole. So I'm going to plug this into my factor, and I'm actually going to plug that into the factor of all of them. And let's just see what this is doing here. So we're going to take the bottom and leave it white. That way it won't taint the color, so everything outside of that will just remain the same color. But inside here, I'm going to turn red and green up so that we get a yellow color. And then I'm going to plug this into, let's see, the bottom socket of this one. And from there, I'm going to turn it red. So let's turn all of these down except for red. Turn that up to red. And then I'm going to plug that into my last one here so that the inner portion of that now will turn to black. And of course, I'm not visualizing that. So if we look at that, we see that it starts out as just a normal color, white or actually gray, and then it kind of turns yellow, and then it kind of fades to red, and then it fades to black. So now what we are going to do, we're going to visualize our material again, and I'm going to plug this into the color. And we might see that some of our stuff disappears. But nonetheless, we've gotten rid of the stuff in the middle, and it looks kind of like a cool black hole. One thing I want to do, I'm going to go over to my world, just because it's kind of fun to visualize it this way. I have a checker pattern. I have this kind of nebula around our black hole scene here, and we can see how the black hole is warping that. The light from behind, we kind of get these kind of ring sort of patterns around it. And that's really cool. But what I want to do is I want to visualize what would happen on like a grid background behind it. So let me just turn on the checker pattern texture, which looks a little bit funny on the world background, but that's fine. I don't know. I think it's just cool. I think it's just cool to see how this bends light. So again, because we have it fading to having basically no refraction at the edge of this sphere here, which again, we visualize as just a sphere. That's the influence of space around it. Then it looks like it's just easing in to not bending light and then to bending light. And I think that's pretty cool. I think that's pretty fun. I'm going to turn my compositing stuff back on because it looks kind of cool. But yeah, so I just fixed up a couple of things. That's another word whisker. I always say that. But yeah, when you watch yourself on recording, you realize all these things. But anyway, I think that's a really cool look. And if you are making a black hole at home, then you can now go on to create a scene. Maybe I just created this this kind of nebula that you see in the background. I just created that on the world background. But maybe it would be cool to actually have it be real volumetric nebulas around your scene. Although you probably wouldn't need to, because of no matter how big black holes are, there are some very large black holes, but still they're technically small compared to the size that an actual nebula would be. But nonetheless, you could go on to try different things with making the background look different, look fun with the nebulas, or maybe put some planets around there with atmospheres, which is something that I want to show you guys how to do in the future. And unfortunately, I do not have a super fast computer, and I cannot resist but to look around this stupid thing, which makes it keep having to to render. So I'll just sit and let that render for a little bit, and I think I'm going to bring an end to this live stream for just a little bit. So thank you for watching, if you're watching this live, or if you're watching this on the replay. Again, I know that my viewers are very smart, and you can use the tips that I have given you to do a lot cooler things than I even did here. So I look forward to seeing what you guys do, which you can feel free to share with me. Actually, if anyone makes something based on this video or any of my other videos, I am on Instagram, which my username is the same as it is here on YouTube, Nerdcraft, nerd without an E and craft with a K, no space, no capitals. And I'd love to see what you guys come up with. In the future, I'll probably make a video showing how I made this compositing here. I am so excited that in the latest version of Blender, we have real-time compositing here, so I can actually see compositing in my viewport here. I have some fog glow, some bokeh here, which is a little bit difficult for my computer to process, but I have it in there nonetheless. And it just helps to make, even just looking in your render while you're working on something, looking in your rendered view in the 3D scene, it helps to kind of helps you visualize how cool things are going to look in the end, actually. The only thing I would like to fix, which I don't know quite how to fix, you notice how our black hole kind of dips down here. Let me go full screen here. Our black hole kind of dips down, and that's the effect that we had of doing that coloration stuff that we did, where we shift it to red and then to yellow and then to black. It unfortunately does cut off things that are in front of the black hole, just because we're doing this on the surface. So I actually kind of forgot about that little problem and don't know exactly how to fix that, but hopefully it's not too big of an issue. And if I find a way to fix that, there will actually be a card right up here, probably. So yeah, just really fun making black holes and stuff like this. So I think I'm going to end this live stream, but I'll just let you guys know what I have in store. So next week, I am planning, hopefully I have enough time to actually finish and prepare by then, but I want to show you guys a galaxy generator that I am working on. A node, or maybe a few nodes that we'll be able to use to make almost any kind of galaxy that we see in images on Wikipedia or whatever from NASA, from spiral galaxies or barred spiral galaxies or elliptical galaxies and so forth. So I'm working on that. Maybe next week that's what we will do. And also planets. Making planets is very difficult, especially if you're doing it all procedurally. Although in some ways it's actually easier to do it that way. But I would love to show you guys how I create atmospheres and clouds in the atmospheres and continents and oceans. And not just how to do it, but also, besides just the visual aspect of how to make space art look cool, but also how to think as far as adding accuracy and realism. Which, of course, most of us in our day-to-day life, we don't know all of the technical aspects of creating planets and space art and how gravity works and how that affects a planet and stuff. But I'll try to break it down into something that's very easy enough for me to understand, so certainly easy enough for anyone else to understand. So thank you guys for tuning in. I hope you find this useful, and I hope that you're able to show up for my next live stream.